Hey, hi guys. I welcome you to the call. I think there was a problem with the audio because of the broadcast button was not actively working. Sorry for the delay. I think we'll have to go over this once more. So I welcome you all into the webinar. So we are today trying to cover the fine details about our workforce wellness solution. The objective is to cover the monitoring and the management of employee wellness and well-being using wearables such as Samsung watches and the real-time management and monitoring and management. That's the focus of the solution. So we have a set of agendas here that we've set in here for today's conversation. So the key point of today's discussion is just to give a brief about who we are, the challenges that we face, the challenges we foresee prior to developing a solution, and a deep dive into the solution itself and some of the use cases. So before I start on who we are about EIL Global, let me just give a quick introduction about ourselves on who are in the panel and at the speaking desk. So I'm myself, Abdullah Schneier. I'm from Adelaide. I'm part of the operations efforts for Australia, and I've got John Bond from Melbourne. He is responsible for sales in the region in Australia. And we've got Grant Young from Auckland, New Zealand, who's responsible for sales in New Zealand. And we've got Selvam from Auckland as well as part of operations. And we've got Rakesh Kumar, who is part of marketing team for APAC region. And we've got our partner and distinguished guest, Joe Head. He is joining us today on the call from Arizona. So that's about the people behind the panel and the call today. And regarding questions, if you've got, please feel free to ask any questions at any point of time, and we might pick up those questions, read them over, and we'll have our panelists answer those questions. This is a brief about EIL Global. So the story is about the evolution of EIL Global. The EIL is Evolve, Innovate, and Lead. That's what EIL stands for. And we have evolved from a conventional IT services provider playing in professional and managed services space. We are in the space from 2010 onwards. We've been focusing on Cisco, Microsoft, and Avaya platforms. And over the course of the years, we've gathered experience and expertise in some of the other technologies, as you see here on the Cisco Unified Comms, routing, switching, storage, and cloud platforms. And in the due course, we've acquired customers ranging from small, medium to large businesses. And as you've seen here, and our legal entities are all across Australia, New Zealand, and APAC region. We're headquartered in Australia. Headquartered in Adelaide in Australia, and we've got our offices in Auckland and New Zealand, and we've got other regions in APAC. As we see here, we are backed by about 200 plus staff in the region. So we have evolved from a conventional IT services provider to a contemporary IT services provider by adopting the modern day IT services technologies such as AI and blockchain technologies. And we work with large and small, medium system integrators and other enterprises while we also address their conventional IT problems. these are some of the challenges that we face towards development of solution itself. And I would like to have the conversation over to Joe, who is going to give us a bit of more background about the evolution of solution and evolution of GoX Labs and the Ergo solution, and an insight towards the challenges that we face nowadays, so that we can take this conversation forward. Thank you. Over to you, Joe.
Great. Well, thank you, Abby. Again, this is Joe Head. I'm the CEO of GoX Labs. We are based in the United States, and we're very happy to be partnered with EIL Global in Australia, New Zealand, and Singapore as we move along and work on these challenges. So what is the challenges, and then how do we solve these challenges? So when we think about workforce safety, illness, and injury, it really is a spectrum of challenges. From on one end, you might have illness, and then you have safety, and then you have injuries. All of them are related together as far as the worker is concerned. So some of the key challenges include overexertion injuries. Matter of fact, overexertion, so fatigue type injuries, represent about 35% of all work-related injuries, and is by far the largest that contribute to workers' compensation costs. And it is probably the most common factor in all types of different workplace injuries. In other words, fatigue is central to all. And risk increases with increase in other factors named here. In other words, overexertion injuries increase when there is heat illness injuries, or overexertion injuries may increase when there is influenza-like illness. So because of that, what we've developed is this all-in-one solution. You've got overexertion injuries, which is an area that we focus heavily on. And then you have heat illness, which is another threat to health and operational success. And by the way, with global warming, this is increasing by over 200%. Each heat injury costs 130,000 Australian dollars. And by the time the temperature reaches 30 degrees C, your productivity goes down by 14%. So you can see how heat injury and overexertion injury are related. And then in the middle is musculoskeletal injury. Workers injured on the job every 7 seconds. This equates to 540 work injuries per hour. A back injury can cost as much as 105,000 Australian dollars. And by the way, your musculoskeletal injury risk goes up when there is higher temperatures and you are fatigued. In other words, those are correlated. And then the final one, this is the one that we're dealing with today in a lot of ways, and that has to do with your injuries and your illnesses and your flu-like illnesses, your COVID-19s, and so on. What I would like to say about that is, in Australia alone, 5 to 20% of the population gets the flu, which is about 15 to 3,000 people, and 15 to 3,000 people die as a result of flu-related injuries. So just the flu alone is a really big problem. In the US, 20 to 60,000 people die of the flu on a yearly basis. We know in the last decade, we've had MERS, SARS, and now COVID-19. And all of these are born out of mammals. And there are over 1 million of these viruses out there that's estimated within the animal population. And as people get closer to one another, and we bring these animals from all the different continents into wet markets, the chance of another COVID-19 happening again only increases. So that's a challenge. It affects our workforce. And so what we have to look at is a all-in-one holistic solution that addresses all of these, because by fixing illness, we might be able to fix 30% of safety. By fixing musculoskeletal injury, we might be able to fix 25% of overexertion injuries. Again, I'm happy to be here, and I'm going to turn it back to Abby.
All right, thank you, Joe. So we're going to move to the next deck. So we're going to talk a bit more about our purpose, right? So like what Joe was saying, so we've got those different challenges that Joe was mentioning in the previous slide, and expand it further. So that's what our objective, or rather our purpose, is to help the workers to become more healthy. So the objective is to understand what is the statistics of the current workforce that we see here. We see about 55 by about 2030, about 18% of our labor force is going to be over 55, and about 9% of adults with diabetes, and about 52% of adults obese, and we got a huge percentage, that's a 76 whopping percentage here. They could be struggling with the physical well-being. So we are straight away targeting to address these areas. So about 80% of the chronic diseases and about 100% of the workforce-related injury are preventable. So all the majority, or rather all of the issues that we have addressed during our challenging phase, that most of them could be preventable. That's what we say, about 80% of chronic disease and about 100% of workforce injury are preventable. That means we could save about 35 billion of about Australian dollars for treating chronic diseases, and about 28 billion for work-related injury and illness. So that's what we could prevent, and that's what we could save. So our goals are definitely to run or have an expertise that you can trust, an ROI that helps in saving the cost, and a novel solution using the state-of-the-art AI technology, to help and innovate and address these problems. So I'm putting it back over to Grant Young from Auckland to help us a bit more about the details of the solution, and he can take us through the same. Over to you, Grant.
That's great. Thanks, Abhilash. If you could just move the slide forward, I don't have control. Thanks, Abhilash. So yeah, the main factors to consider with the Ergo solution from GoX Labs is to look at the whole issues around sickness, employee sickness, and employee injury. So we have a holistic view from the workers' fitness environment and their work conditions. We have a dashboard on the computer which establishes the details, or you can look at the data of the information which comes from the pods, which are worn on the body of the employees. And then we look at the workplace safety issues. So is the temperature around the area too hot? Is there dangerous issues with regard to the worker safety? And we can prevent and reduce the injury by looking at the fatigue, the dehydration, thermal stress, and the movement. So GoX Labs has refined over many, many years algorithms with the US Army that determine these factors. And dehydration is quite a large one, where a lot of injuries and accidents are caused through dehydration. That often comes with the environment. So if the environment's very warm, or if they're working in a factory perhaps, or a large warehouse where the temperature is too hot, that can also have an effect. And by looking at all these factors and making some changes through a proof of concept initially, then workers' environment and the way they work and their productivity can change. So we can just move to the next slide there, Avalanche. And so, as mentioned, the little pod you can see there, the black one, that's worn on the collar of the shirts, and it registers the movement of the user or the employee. And so effectively, they, depending on how much they move forwards and backwards and how often they move and how quickly they move, the algorithms can work out the stress on the body. And this is all correlated back to their heart rate, the temperature, and a bunch of other factors. And so the information gets redirected through Bluetooth down to the smartwatch, and on the smartwatch they can see, monitor the heart rates, the good lifts and the bad lifts. On the left you can see there the number 30 is a good lift and number 18 is the bad movement, torso movement. Each person has their own risk factor depending on their height, weight and age, and that's all built into the algorithms as well. And none of the information, in fact, shows on the dashboard in terms of their name or identifies the personnel. So it just comes up as purely a number on the system, and effectively the person monitoring the data can just see the user numbers. If you can just give me control there, Avalanche, I can bring up the dashboard. Thank you. So we can see that okay? So the dashboard, each company has their own dashboard, and you can set up various users within that as a group. So over here we have a number of users, and as I said, they're mentioned, there's no name mentioned, they're only showing up as an ID on the system when they were last active. And if you look at the activities, I in fact used a pod and a watch this morning. Actually, I didn't use the pod, just the watch. We can look at the summary of the risk factors. Joe can describe this a bit more in detail perhaps, but effectively by looking at all these factors, we can be alerted to any good movements or bad movements, the peak heart rate and the average heart rate, dehydration risk. And the watch actually vibrates every so often and reminds you, have you drunk some water? Or if you've got a bad lift or a good lift, it'll actually also vibrate and give you a warning signal. Being a Samsung watch, it also has some other factors built into it. So if you're going for a run or a walk, or if you're a courier perhaps moving around quickly, it will actually also vibrate if you're moving too quickly or your heart's elevated. We won't go into the data now, but there's a lot of information can be gathered in terms of the environmental temperatures, the heart rates, and the risk factors, torso movements. And there's also a new version coming out soon which has some insoles built into the shoes, and that allows us to look at the pressure on the body in terms of weight, left or right, or forwards or backwards. Did you want to add anything to that, Joe, before I move on to the next slide?
No, I think that's great.
Okay. So we can go back to the slides, Avalanche. So we've sort of mentioned a few of these factors already, but effectively it's movement, the fitness and fatigue side of things, and the thermal stress and dehydration. So thermal stress and dehydration is all around the temperature of the environment, and certainly in places like Australia in the summertime it can get pretty hot, not so much in New Zealand. Fitness and fatigue in terms of the person's heart rate, and you know, if that's elevated or even not necessarily smooth, the algorithms can pick that up and determine that there is a risk factor there, perhaps down the track. Apparently the algorithm can even work out that the person may be getting a virus or flu symptoms 72 hours before the actual effect might happen. Next slide, Bush. So the algorithms over many tests over many years have proven that at least a reduction of 20 to 30% in back injuries, 50% reduction in the exertion risk, and a 30% reduction in the claims, which can be very expensive. If a worker is out of work for at least several weeks or even perhaps 2 or 3 months, the cost of that through the government and certainly through the loss of production is huge. Next slide. Yep. So the industries we're looking at, the GoX solution with all the algorithms can cover a whole range of industries. Certainly through Joe's experience working with the military for many years, he can describe, how that's worked very well for the military. But pretty much all industries could use this very effectively in construction. The police forces, couriers and transportation, baggage handlers at the airport. Pretty much anybody who's moving, where there's a environment where the temperature could be up or down. The person's stress could be certainly increased due to the various work conditions. And even people sitting around for too long, perhaps in cranes or tractors, earth moving equipment, they're also at risk because they've been sitting around, their body's tightening up, and they could actually be at risk just in terms of their heart rates, if they're not very healthy, perhaps. Certainly with the insurance industries, there's a huge cost saving there, I believe, with the injuries being reduced. Insurance companies could certainly save some money, and certainly ACC could as well. So the watches are currently powered by Samsung, and the pods and the insoles and the wearable equipment is provided by GoX Labs in the States. EIL Global for New Zealand, Australia will provide these and provide the support and the solution. So we just go back to the use cases now. I believe Joe might describe some of those for us.
Yeah, thanks, Grant. This is Joe again. As Grant just mentioned, this has been developed over the course of a dozen years in the US government. So I spent over 20 years in the military, part of that at our military academy, and then 4 years at our Department of Defense's premier research organization called DARPA. And there we focused on human performance and workforce injury, because workforce injury in the US military was the key problem for evacuation from theater and also from being kicked out of the military. And so because it was such a big problem, we've worked on it for many years. And so here, we say 12 years of R&D in the US government, over $100 million spent to kind of come up with the models that we're using today at GoX Labs. One of the studies that we did at GoX Labs under a contract from the US Army was to develop a metabolic expenditure estimator on a watch. So without a mask, be able to estimate how much energy a person is consuming in a very accurate way. And so what this graph is showing is one of the results from that 2-year study with the US Army, where we predicted energy expenditure, that's on the vertical axis, that's in watts, and then measured in the horizontal axis. So measured is using a clinical grade oxygen consumption mask. And then we compared that against our algorithm on a watch. Each blue dot that you see represents a person doing something. Activities range from walking all the way to running, with a 40% of body weight load at temperatures above 40 degrees C. And so those are near 1,000 to 1,200 watts. So those are those dots closer to the right side and to the top. So you can see 1,000 to 1,200 watts. And then you see a clump of people near 100 watts. Those are people walking. And if the prediction was 100%, every one of these blue dots would line up on that red line. In other words, if the metabolic cost estimated was 1,000 watts, then our prediction from the watch would be 1,000 watts. Therefore, it would line up exactly on the line. But you can see that we're very close. Matter of fact, our accuracy was over 95% across all of those people doing all different kinds of activity, men, women, 18 all the way up to 60 years old. Next slide, please. So here, what we're showing is kind of what I suggested up front with the challenges. Because injury is so complex, we can't just measure one thing and expect to understand and to prevent injury. So one of the biggest correlation to injury that ergonomics people and occupational health people work on is kinematics. So that green dot in the middle, kinematics. We know that there's a strong correlation between how you move and injury. But the thing is that what affects the way you move has a lot to do with your level of fatigue, because the way we move a lot of time is motivated by metabolic efficiency. In other words, we try to move in a way or lift a box in a way that requires the least amount of energy. So we bend at the waist and we pick it up, even though we know the right answer is to bend at your knees, bend at your hips, and recruit all the core muscles like your quadriceps, your glutes, your back muscles to pick up that load. But that requires more energy. So fatigue and kinematics has a strong correlation. But we know that kinetics and injury has a strong correlation, meaning forces. You higher the load, more likely the injury. But did you know also that there's a strong correlation between individual fitness and fatigue? And if it affects fatigue, it's going to affect kinematics, which affects kinetics. In other words, there is a strong correlation between fitness, fatigue, the things in the middle we call form, and the things at the bottom we call forces, and the environment. So those are the 5 key things that affect injury. And so we've developed algorithms and sensors to be able to measure fatigue, measure form, measure forces, measure fitness, and measure environment so that we can predict and prevent injury. Abby, would you like for me to address this slide, or did you want to take over?
Yeah, I could do that. So thank you for that, Joe. I think there are so that's just the the analysis of a few of the studies that GoX Labs have done in the and which has helped in shaping up, evolving the solution itself. So this is one of the use cases or examples where we could use the solution with respect to a bit of a gamification overlook into it by providing information on each of the soldiers. Like we see 3 types of coloring with respect to the fitness levels of the soldiers. So this is the one on the right is what we see for each and every soldier, wherein we've got a group or squad view for each of them, where we see green, which says they're good, and the amber and the red. So these are the three different ranges of fatigue levels, of dehydration levels that we've seen here. And so this kind of a real-time monitoring of the teams and the individuals that could help in shaping up a workforce that is injury-free, and we can optimize the effort or the productivity of the workforce as well. So this is a typical example of how we could use our use case, or how we could use the solution with respect to the military or the police force, for example. And the first responders, as we see here, compared to more or less similar to what we have discussed earlier. So when we have a typical, heat-related issue with respect to firefighters, especially in the summer times in Australia, that we've seen the heat stress is quite a bit of a stress for first responders, especially the firefighters. Where a heat injury could cost about $130,000 each of them. And we also should know that at about 30 degrees, the productivity could dip by about 14%. These are all figures we've discussed earlier, but the key takeaway with respect to the first responders is to enhance the team's performance and overall department performance, and thereby improve the protection that we could give to the first responders. That's one of the best use cases that we can depict of the solution. And these are some of the use cases. I think Joe can put a bit more light in here, because this is, I think, with respect to a testing group of about 7 workers, and we've got different treating elements in the outcome here. So Joe should probably able to take us through it in a better way.
Happy to.
Over to you, Joe.
Yeah. So everything is data driven, and we use the right metrics, and that's what we're showing here too. So that the way what you're seeing is that in this case 7 workers working outdoors, and the heat index, which is a combination of both temperature and humidity here, and I apologize, it's in Fahrenheit, is the heat index is above 100 degrees Fahrenheit. So it's pretty warm. And what we've done is on the left side of the graphs, where for heart rate, VO2, and average risk is before treatment. And then we've implemented the treatment. What is the treatment? So treatment elements included the haptic cues from the watch, which tells it vibrates and tells a worker, hey, you are starting to dehydrate, you should drink some water. And you might want to take in 100 calories every hour. Or, hey, your heart rate is going up very high and your VO2 is getting up very high, you may want to take a 5-minute break. And so those are kind of the feedback the watch is providing. And by the way, hydration, by the time you feel thirst, it's too late. That means 2% of your body weight you've lost in water by the time you feel thirst. So we really have to start to warn you once you hit 1% of body weight. And so those are the type of very proactive treatment elements we put in place. So what's the outcome? So what happened once we put that treatment elements in? Well, you can see at the bottom kind of what it says. So heart rate goes from 120 to 100 beats per minute with treatment. In other words, the heart rate of the 7 workers goes, the average 7 worker heart rate goes from 120 beats per minute to 100 beats. The VO2, which is the volume of oxygen consumed, which is the key metric for functional capacity. It's the best way to know, are you overexerting yourself? Are you being efficient? How much energy are you consuming? So that's VO2. In this case, the units for that is milliliters per minute per kilogram. And it goes from 12 down to 11. That might not sound significant, but in terms of VO2, that is very significant. So the amount of energy consumed to do work went from 12 milliliters per minute per kilogram to 11. And by doing that, we were able to reduce the average aggregated risk. So the aggregated risk takes into consideration your musculoskeletal injury risk. It takes into consideration your illness risk, your thermal stress risk, your dehydration risk. It takes all of those together and averages it to a single risk score. And what we are showing here is that the average risk went down from 0.6, which is bad, to 0.4, which is amber, which is a 33% decrease with treatment. Here's another one where the test group is 10 people, and the treatment elements in this case is similar in that it's haptic and display cues from the smartwatch with hydration, nutrition, and rest. And if we can look at the first graph, which is the heart rate graph, you see the vertical axis is beats per minute. So that's your heart rate. And then you can see days of the week. So day 1 through 5. And these are 2 different weeks. So on week 1 is the blue line, which is without treatment. And then week 2, which is the orange line, is with treatment. So within the blue line, all we did was we put the watches on the 10 workers and we just measured. And what we found was this: on day 1, when the temperature was 99 degrees Fahrenheit, which is very warm, the average beats per minute was 100 beats. Then by day 3, when it goes to 100, the average beats per minute was 115. And then when it cooled down to the coolest of all the days, 93 degrees Fahrenheit, the temperature goes back down to 93 degrees Fahrenheit. When the temperature goes down to 93 degrees Fahrenheit, the average beats per minute is 100 for the 10 workers on day 4. And then you can see in day 5, when the temperature goes up to 97 degrees Fahrenheit, the average beats per minute is 105. In other words, there's a close association with temperature and heart rate. And that is typical, right? We think of that as cardiac drift. And we see that in normal working groups. Now, on week 2, we turned on the haptics and displays, which reminded people to hydrate properly and eat properly, and look at what has happened. On day 1, it was 103 degrees Fahrenheit, which is the hottest of all of the days tested. The beats per minute is 100. The next day, it's 103 degrees Fahrenheit, and it's actually below 100 beats. The third day, 103 degrees Fahrenheit, it's 100. Day 4, it's 102, and the beats per minute goes all the way up to 115. So on that day is the highest heart rate average of all the days. Temperature-wise, it's similar to all the other days. Now look at cadence comparison, which is the next graph over. If you see on day 4, the steps per minute on that day was 75 steps per minute. In other words, the workload was the highest that day compared to any other day, because if you look at the workload of the other days, you can see it's somewhere between 50 steps per minute to 65. And then, so it makes sense when the workload is high, the heart rate is high. But it wasn't because of temperature, it was because of workload. So what we were able to do with treatment was to reduce the heart rate's sensitivity to temperature. In other words, we were able to make the people much more resistant to thermal stresses. In this use case, the key things that we want to be able to show is that we are able to, with a test group, this is a workers in a lettuce field, so agriculture in the United Kingdom, and we are looking at 3 workers. So blue, orange, and gray are 3 different workers, and then the yellow bar is the average of the 3 workers. And so let's just look at the average. And the treatment is back support system that we've added to the lettuce workers. And what we're able to do is clearly show the efficacy of that treatment. How do we do that? Well, look at the total lifts. So the number of lift count. So this is how many times they went and picked lettuce, increased by over 50%. The ratio of good lifts to total lifts. So then using good form versus using bad form. So good form increased by 80%. So the number of lifts went up and the use of good form increased, but the VO2, so the amount of energy consumed, went down by 25%. And another productivity measure is step count. And you can see the step count has gone up as well. So not only was the treatment effective, but what this use case also highlights is that we can very quantitatively measure improvement in lifting form, improvement in overexertion, and improvement in productivity.
All right, thank you very much again, Joe. So just to summarize the whole solution, so these are product to Ergo. So the solution protects the workforce, and we also focus on identifying the spread of diseases and illnesses before it spreads and causes further problems. So we the app protects the workforce by the upstream prediction of diseases and injury, by providing accurate information in terms of predicting illness, and empower wellness by even predicting influenza like illness up to 72 hours prior to the onset of the symptoms, and also COVID-19 accuracy in terms of predicting the presence of the virus. That can be even differentiated between an influenza and a COVID-19 one. And there is a fairly new addition to the Ergo solution itself, which is a more advanced version that's called Boost, that's coming up. I think Joe can bring us a bit more light into what's Boost for us. I think it's predicted to be launched by towards the end of the year, Joe.
Yes, so Boost is, think of that as the Ergo 2.0. It's the next major upgrade to the capability. So we will obviously continue to focus on musculoskeletal injury. We're going to continue to focus on dehydration and thermal stress. We've now included illness detection before the onset of symptoms. We're working with Northwestern University now to finish up our COVID-19 detection. But we've also added on top of that proximity sensing for social distancing and lone worker safety. That lone worker safety, if you want to turn it on, you can know where that lone worker is through the GPS. That's optional. You can turn it on or off as an organization. And we can color code those icons on the map as green, amber, red based on their risk scores, and you can maintain health status of those workers. So there are 5 different solution sets under Boost, and for the first time, we have added a meshed optional set of mesh network of sensors. So if you want to put a sensor on the shirt collar to assess trunk movement, great. If you want to put a motion sensor at the upper arm to assess shoulder movement for overhead work, if you want to put insoles into shoes and have that connect back to the watch so you can look at risk of slips, trips, and falls in workforce or in the elderly, you can do that. So Boost is about expansion of the solution in an all-in-one app, and also expansion across multiple sensors that all feed information back to our third-party watch, our Samsung Galaxy and Active 2 watches.
All right, that was pretty comprehensive. I think we've got a few questions. So one of them is, so we have seen Samsung in 2 slides before, and but we've not seen anything with respect to Apple ones. Do you provide similar solution around Apple watches as well, or is it limited to Samsung?
So Abby, I can answer that. We have a iOS a Wear OS, which is the Apple's watch app. That operating system is the Wear OS. So we do have a Wear OS app developed, and we also have an iOS, which is the phone app developed, and it's currently in testing, and we expect for that to be out in the 3rd quarter.
All right, so another question is, do you have a treatment plan along with the analysis? And if so, does it also cover ergonomics?
Yes, I mean,
I think it means, yeah, do we consider the ergonomic factors into the treatment plan?
Definitely. I think we were first and foremost focused on ergonomic assessment. So, for example, those motion sensors that are assessing movement risk are based on ergonomic principles. So we establish risk based on the different zones the person moves in, either in the sagittal plane or the coronal plane or in the transverse plane. So those are very much ergonomic principles. And then, the references and the standards we use are based on things like rapid entire body assessment, REBA, and RULA, which is the thresholds are based on standards under OSHA and NIOSH. So yeah, very much so. Now, what the difference is that we also incorporate sports science because we know that those movements are a lot of times motivated by metabolic efficiency. And so we want to know what the related VO2 is for that movement. And then we need to strengthen those core muscles to reduce the metabolic cost of doing good movements. So we incorporate both of those. But having said that, we started with ergonomic principles, and then we added sports science and material science and thermodynamics and heat transfer to be able to come up with all of the models that we've developed.
Wow, this is an interesting question. So it says, I understand VO2 has an impact on the height. So does the solution or the algorithm of the solution, does it analyze anything with respect to height risk that could be associated with construction workers, probably using some sort of sensors or analyzing the VO2 data?
Yeah, that is a great question. Currently, our models do not include elevation data. What we do include is temperature information, because temperature has a very significant effect on VO2. Humidity has a very significant effect. So we include temperature, humidity, the person's fitness level, and so on, together with the amount of energy the person, so kinetic energy and the potential energy of what the person is doing. And that helps us to estimate VO2. Having said that, I definitely agree with the question, which is that elevation and the amount of oxygen available will affect VO2.
All right, another question is, does the solution help in identifying the injuries or stress levels for truck drivers?
Yes, like we said, VO2 is the best measure of fatigue. And why do I say that? So when a person, let's say, is doing some standard task, any task, walking, their VO2 level, let's say, should be 8 milliliters per kilograms per minute. But let's say instead of 8, that day, that driver, as he or she is walking to the truck, it's up to 11 milliliters. In other words, that person has to consume a lot more energy to just walk. What that tells us, that's just one metric. There are others like resting heart rate, recovery heart rate, things like that. But we can look at those metrics and tell you that the worker is already fatigued. It may be because they didn't get enough sleep. It may be because they drank too much alcohol and they're dehydrated. But regardless, we can tell when a worker, a driver, is fatigued before they get into the cab. So I think that's probably the unique thing we can offer. And then on top of that, with Boost and our lone worker safety solution, we can track the driver's location through the watch. You can, if you have cellular coverage where the worker is, through the watch, you can communicate, you can send alerts, and we can maintain health status of that driver.
All right, thank you very much. So thank you, everyone. So if you've got more questions, please write emails as you see here, or we're happy to answer any calls. If you've got any questions around it, you've got numbers in here, please get in touch with us. We will be happy to provide any answers that you might need towards addressing any of the workers' wellness solutions. Thank you very much, Joe, and to everyone on the panel, Grant, John, Rakesh, and Selvam. So it was very nice to have you all in here, and we shall hope to hear from you guys sooner.
Thank you so much, Vilash. Thank you, Joe.
Yeah, thanks, guys.
Thank you, Grant. Thank you, John.
Yeah, fantastic. Joe, thank you.
Perfect.